In this video, we'll be doing the 8th experiment. This is about design and obstacle detection using ultrasonic sensor. So what we'll have in this experiment is we will have NodeMCU. It's connected to, on one side, it's getting inputs from the ultrasonic sensor and it will measure the distance. And if the distance is very close, for example, if the distance is less than 20 centimeters, obstruction is less than 20 centimeters, then it will activate the buzzer in the LED. And it parallelly will also keep displaying the distances that we have measured on the Arduino ID. It's a very simple experiment. So let's go to the circuit diagram. Circuit diagram is like this. We have the NodeMCU. In fact, you can parallelly see the live feed also. We have the NodeMCU. And then we have this ultrasonic sensor over here. It has 4 pins. You can see the ultrasonic sensor over here, and 4 pins over here. One of them is a transmitter, and the other is a receiver. So we have VCC, which will be connected with the NodeMCU's power, and ground. Likewise, echo and trigger. These are the 2 pins that will be using D1 and D2. And even though on the board we'll see it as D1 and D2, but actually the GPIO numbers will be different. So in fact, in the manual it is given over here. D1 is GPIO 5 and D2 is GPIO 4. And then we'll also have a buzzer, which will be connected to the ground, and then D3. D3 is GPIO 0, like you can see here. It's a simple circuit. So here's a code. It's a simple example. So I'll just copy the code and paste it into Arduino IDE. So here you go. So copy the whole thing. Come here. Let me remove everything and paste it afresh. Paste it afresh. So you can see the pins configured over here, trigger pins and echo pins, buzzer pins, and then they can set to output, input, and output like this. And then in the loop, you can see it's a very simple one. So initially, what we'll do is initially we'll do a digital write to the trigger pin. We'll clear it. We'll make it low. We'll wait for 2 microseconds, and then we'll send a high on the trigger pin. We'll send it for 10 microseconds. And then, yeah, this is a pulse that we're sending for 10 microseconds. We made it high and then we made it low after 10 microseconds. And then on the echo pin, now we are measuring the pulse the duration it took for it to come back. And we know ultrasonic center works on the concept of sending sound waves. Then we know the sound travels with this velocity. And then round trip delay divided by 2. That's the region. That's how we get it in distance in centimeters. And we're printing this. Likewise, if the distance is less than 20 centimeters, we are activating the buzzer to high. And then else we switch it. And we are conducting this every half second. So we'll just compile this and upload it into the NodeMCU. Before that, make sure that the port is appropriately selected and NodeMCU is appropriately selected. So right now it's uploading into the NodeMCU. And we can, let me also bring the feed. Here's the feed. You can see right now it's writing, still uploading. Yeah, once in a while you'll see the LED blinking over there. Yeah, it's uploaded. And let's make sure we have the baud rate correct. Now it's measuring. Every half second it's measuring the distance. Now let's bring some object close by to it. So we have the ultrasonic sensor and the microphone is still not in the video. Yeah, I got the phone over there. So you can see it has started buzzing. And then you can see that the centimeter is showing. Let me have it. When my phone goes past, or let me, yeah, add them together. We have the phone very close by, that's why you have 6 centimeters. I remove the phone, I lift the phone, and then you can see it has stopped. Then I will let it come 6 centimeters. Bring it closer, 4 centimeters, 2 centimeters. Okay, this works. Okay, that's our objective. Let's stop here. Thank you. See you in the next video.